converter. Normally, this is a frequency changer. Input is three-phase supply. Output also the three-phase AC. You cannot directly change the AC to AC speed. AC is a sublime body frequency only the 50 Hz. So output body frequency is variable. The speed wave is variable. The frequency wave is variable. But according to the AC body nature, you can reduce the voltage, you can increase the voltage. If you use the transformer, step transformer, you can increase the voltage. Step down transformer, you can decrease the voltage. You can easily increase and decrease the voltage level. But you cannot easily increase or decrease the frequency. Frequency increase, decrease, you cannot done directly. So because of this one, instead of directly changing the AC frequency, we have to use a sub-breaker step. Firstly, input AC is a three-phase AC system here. Three-phase AC voltage is to be converted to the DC voltage. So this is the converter. So this is the DC voltage. Okay, this is a DC happen here. And then this DC voltage we can use as a PWM circuit or pass with a modulated circuit. So this is a PWM circuit. PWM as a PWM means a pass with modulated circuit. And this PWM circuit we can utilize. So this is they began as the variable waveform DC. Gradient the signal. And this one maybe you can convert it to the inverter. And then convert it to the three-phase AC. So this three-phase AC is now connected to the AC motor. So procedure has to be followed. You cannot directly increase or decrease the frequency. You can easily increase or decrease the voltage. If you use a step-out transformer, depending on the number of turn ratio, you can easily increase or decrease the voltage level. But frequency increase or decrease, you can do that easily. So first thing is you have to change the AC voltage to DC. So in this case, we use a converter system. Converter means the devices that change the AC voltage to DC is a converter. And then this DC voltage is we use a pathway modulator circuit. Pathway modulator circuit means that this piece DC piece voltage are they changing depending on the pioneer circuit, the cutting off circuit, the voltage level will be changed, and then so inverter will change the AC. So now we talk about the pathway modulator system, PWM system. How to use a PWM system? PWM system means that for the switching, they got a switching waveform to include the switching circuit. Switching circuit means that this is the DC here. DC voltage you use an electronic switch here. So this is the switching circuit. These switching circuits are driven by the gate control. So this gate control provides a triggering signal. So this gate control triggering signal, so this one becomes a variable amplitude output wave. They happen like this. So this input is a constant DC here. Constant DC is inserted to this circuit. So this is a gate control circuit. This is the pathway PWM circuit. PWM circuit got the electronic switch. This is we go the electronic switch. So this electronic switch are driven by the gate control. So this gate control means that it's an on and off the circuit. So on and off the circuit, so then we produce the variable amplitude. So this switching the wave frequency waveform determine the output voltage amplitude. For example, the switching circuit firstly that we slowly switch the circuit here. So very slowly. Firstly, we slowly switching, and then we use the increase switching. So this increase switching and going down switching. So like this. So this is the switching way. The switching is start like this, slowly switching, and this is increase switching and the slowly switching. So this means that more increase, this is the more slowly. For example, this way, this is you cut off within 1 second or 2 seconds, 3 seconds like this. So you just cut it on the switch within the 5 seconds. That will be the slowly switching. And then you quickly start on the switch, so within 1 second or 2 seconds, it will be the speed will be the faster and faster, the magnitude will be bigger and bigger. So that because of this one, this slowly switching waveform, the waveform, output waveform is this way, is gradually the increase. When we increase the switching rate, volume magnitude will increase, will decrease like this. So this is how we call the step rate like this. So this is the slowly switching. When you increase the switching speed, magnitude will be increased, and then you decrease the switching speed, the waveform, magnitude will be decreased. So this means that increase the switching speed. So this is volume magnitude. It's increased. And here you decrease the switching speed. So then voltage magnitude is decreased. So this is similar to the AC waveform. AC waveform is from 0 to increase maxima and go to 0. So from the 0 to increase, so you're gradually increasing the switching speed, so the output volume waveform will increase, proportionally increase. And then you gradually slow down the switching speed, the output volume will decrease. So that this is for the switching speed. Normally this guy is we use for the but the normal voltage is not this one. This one is a step width. Step sine wave. So this is a step sine wave. Step wave can be produced. Step wave are produced by the switching. Then you have to utilize this step wave to reduce the phasor. Then you can produce the appropriate sine wave like this. So that in this is the PWM circuit. We got the gate firing control circuit. Gate firing control circuit means the gate firing signal on and off the electronic switch. So depending on the switching speed, output will increase or decrease like this. So those waveforms are the step wave. Those waveforms you need to be combined with the phasor. Then you got the pure sine wave. So by this way you can use. And this is for this polarity. And another polarity, opposite half cycle, you have to reverse the polarity of the switch. To reverse the polarity of the switch, then so you provide a negative half. So this is the reverse polarity switch. So then produce a negative half cycle. So this is for the we can produce. So the switch out how we can reverse the polarity. So one polarity direction you got the upper half cycle, and the negative half reverse polarity switch you got the lower half cycle. So the whole waveforms are step waveform, step sine waveform. Those step sine waveforms are produced by the pulse modulator. So this pulse modulator circuit, the producers are those are step waveforms. So those step waveforms, depending on the switching speed, waveforms the waveforms of the signal frequency is depending on the switching speed. So it is also related to the frequency. So this is the DC. So those DC waveforms are transferred to the AC by the inverter, then you provide the motor. So by this way we utilize the PWM system. So in this case, the from the DC machine you can directly change the model plus, but for the AC system, you cannot directly change the AC frequency. Firstly, The AC body is converted to the DC by the converter, and the pathway modulator circuit, electronic switching circuit produces a pathway modulated waveform. Those pathway modulated waveforms are transferred to the AC by the inverter, and then proceed to the motor. So this is the basic system we use this system in the variable speed drive system. So the inverter differentiator we use this typical pathway modulator circuit. All these are converter, inverter, everything are included in this combined circuit. So we change the switching waveform, we can provide the variable speed. So this is an overview of the variable speed drive system. So in the details we study how the converters are constructed, how the PWM will be constructed, how the inverter will be constructed, will be studied in this unit. The unit means this is an overview of the PWM system, the variable speed drive system. Then we detailedly study how the inverter, converter are constructed, what kind of the elements, what kind of devices to be used, what are their rating efficiency, how to make the control circuit, how to process the charge, the thing. And then we combine the overall system application, their feedback control system. So these are included in the unit. So this is for the basis